This video we're going to solve the following question. Determine the value of k for which the function f at x equals 4x squared minus 3x plus 2kx plus 1 has two zeros. So we're basically going to solve for the values of k that makes this function have two zeros. We know that the discriminant helps to identify if there are any zeros and the number of zeros. We know that if b squared minus 4ac is greater than 0, there are two real solutions. If b squared minus 4ac equals 0, there are one real solution. And if b squared minus 4ac is less than 0, there are no real solutions. We are looking for this scenario here because we're looking for two real solutions. So from a quadratic in the form f at x equals x squared plus bx plus c, the a values the values in front of the x squared, the b is the value in front of the x, and the c is the constant. So if you look at the function f at x equals 4x squared minus 3x plus 2kx plus 1, a is just 4 because it's in front of the value of the squared. B is actually negative 3, which is right in front of the x. There's an x here as well, and it's also plus 2k, so this is another part of the number. And then c is just 1. Since we want two zeros, again we're looking for the scenario where they're greater than 0. We substitute b, so negative 3 plus 2k, and then we substitute our a as 4 and our c, which is 1. We simplify this, so we expand negative 3 plus 2k squared, and we multiply negative 4 times 1, and negative 16. Continue to simplify. So you'll see 4x squared minus 12k plus 9 minus 16. Just rearrange it so that it's in the order of exponents. And simplify further. You'll note here that the a value is positive, so we know this parabola opens upwards. We're going to use that information in our final solution. In order to find what would make this greater than or equal to 0, find the zeros of this, we actually have to factor. Alternatively, if you don't want to factor, you can use the quadratic formula. So to factor to solve the x-intercepts, we factor 4x squared minus 12k minus 7, and our two factors are 2k plus 1 and 2k minus 7, which we're setting equal to 0 just to find the x-intercepts. If this is 0, the whole thing is 0, so I set that equal to 0, and I solve to get k equals negative a half. If this is 0, the whole thing will be 0, because 0 multiplied by anything is 0. So again, I rearrange this and I solve for it. I get k is 7 over 2, or 3.5. So if you look at the graph, like I had said earlier, if a is positive, then it opens upward. So I kind of sketched this parabola here. And you'll see in my zeros, negative 0.5 and 3.5. So anything to the left of negative 0.5 is all positive values, and anything to the right of 3.5 are positive values. All these values are negative, which means that there are no solutions at those points. Using this information, we get the final answer that f at x equals 4x squared minus 3x plus 2kx plus 1 has two zeros when k is less than negative 0.5, like I said, it's this side here, and k is greater than 3.5. And there you have it. That's how you solve the following question. See if I can zoom out for you. Okay. Didn't work. Okay, there you go. Not sure if this helps, but this is the final solution to answer. Determine the value of k for which the function f at x equals 4x squared minus 3x plus 2kx plus 1 has 2 zeros. I hope this identified how to solve this particular question.